Ever pondered about the nature of time and reality? Does time flow at the same pace for everyone, everywhere? If you're like most people, you probably assume that time is universal, ticking away at the same steady pace for all. But what if I told you, time is actually relative? This isn't just philosophical musing, it's the foundation of Einstein's theory of relativity. According to this groundbreaking theory, time doesn't tick away uniformly. Instead, it can stretch and squeeze, depending on how fast you're moving or how much gravity is pulling on you. This phenomenon, known as time dilation, can lead to some mind-bending scenarios. For instance, imagine two identical twins. One stays on Earth while the other zips around the universe at nearly light speed. When the traveling twin returns, he would find his Earth-bound sibling has aged more. To understand this better, let's dive into a thought experiment known as the twin paradox. Meet our characters, identical twins Alice and Bob. Alice stays on Earth while Bob embarks on a high-speed space journey. They're about to be part of a fascinating thought experiment that will challenge our understanding of time and reality. Alice, our Earth-bound twin, will be our constant. She'll go about her life here on our home planet, ticking off the seconds, minutes, and hours on her earthly clock. She represents our everyday experience of time, a steady, unchanging rhythm. Bob, however, has a different path. He'll climb aboard his spaceship and blast off into the cosmos, accelerating to a significant fraction of the speed of light. He's our adventurer, our explorer, pushing the boundaries of time as we know it. With Alice on Earth and Bob in space, we're set to explore the intriguing concept of time dilation. How will their experiences of time differ? Stay tuned to find out. And so, Bob's journey begins. As Bob accelerates to a significant fraction of the speed of light, time for him slows down compared to Alice's time on Earth. This is the essence of time dilation, a fundamental concept in Einstein's theory of relativity. Now let's imagine Bob in his spaceship soaring through the cosmos. Inside his spacecraft, time passes as normal. He eats, sleeps, and goes about his daily routine, oblivious to the strange effects of his high-speed journey. He watches the stars streak by, experiences the thrill of space travel, but for him, time keeps its steady pace. However, the story is quite different when viewed from Alice's perspective on Earth. As Bob's spaceship speeds away, Alice watches and notices something peculiar. Bob's clock, visible through a window of his spaceship, seems to be ticking more slowly. A second on Bob's clock takes longer than a second on Alice's watch. This means that Bob is aging more slowly compared to Alice. His high-speed journey through space is causing him to experience time at a slower rate. But how can this be? How can time, which we often think of as constant and unchanging, vary for two individuals? This is where the theory of relativity steps in, shattering our common-sense notions about time. According to Einstein, time and space are intertwined in a four-dimensional fabric known as space-time. The faster you move through space, the slower you move through time. This is not a mere trick of light or an optical illusion, but a fundamental aspect of our universe. So, while Alice on Earth, bound by her relatively stationary position, experiences time at a regular pace, Bob, whizzing through the cosmos, experiences a slowed-down version of time. The process of time dilation is at work. But here's the real head-scratcher. While for Alice, years have passed, for Bob, it's just been a few months. Time, it seems, is not as straightforward as we once thought. And as we'll see, this has some intriguing implications when Bob decides to return to Earth. The story takes a twist when Bob decides to turn his spaceship around to return to Earth. This turnaround is not just a simple change in direction. It is a pivotal moment, a crucial turnaround in our tale of the twin paradox. But why is that so? Well, when Bob veers his spaceship for the journey home, he experiences a change in relative motion. Up until this point, Earth was moving away from him at a high speed. But now, with the flip of a switch, Earth is moving towards him. This change in relative motion is crucial because it introduces an asymmetry in their experiences of time. From Bob's perspective, time is still passing normally. But from Alice's viewpoint back on Earth, the motion of Bob's spaceship introduces a new twist to the time intervals between events for Bob. This means that Bob's return journey is quite different from his outward journey. As Bob heads back to Earth, his clock resumes ticking normally. Or does it? From his perspective, hurtling through the cosmos, everything feels the same. His clock ticks away second after second, just as it did on the outward journey. To Bob, the return journey is an ordinary space travel experience where he ages at the rate he has always known. But let's shift our gaze back to Alice, waiting on Earth. From her perspective, the story unfolds quite differently. As Bob's spaceship starts its return journey towards Earth, Alice's observations begin to change. With Bob moving toward her at a significant fraction of the speed of light, the time intervals between events for Bob, as observed by Alice, are affected. This is the intriguing effect of time dilation, one of the cornerstones of Einstein's theory of relativity. Alice observes that Bob's clock, which seemed to be lagging during his outward journey, is now ticking faster. It's as if Bob is playing catch-up with time. This isn't because Bob's actual aging process has accelerated. No, he's still experiencing time just as he always has. But to Alice, it appears as though Bob is aging quicker than she is. This is the fascinating result of the relative nature of time. This sudden change in the perceived passage of time is due to the change in relative motion between Alice and Bob. During the outward journey, Bob was moving away from Alice, but now he's moving towards her. This shift in direction has a profound effect on how Alice perceives Bob's time. This isn't just a thought experiment. The effects of time dilation have been confirmed through precise measurements and experiments. The twin paradox is a real phenomenon, a testament to the mind-bending implications of Einstein's theory of relativity. Alice observes that Bob's clock is ticking faster now. He seems to be aging quicker, yet this is simply another manifestation of the relative nature of time. Upon Bob's return to Earth, they find something remarkable. Though born at the same time and having been the same age when Bob embarked on his space journey, Bob is now younger than Alice. Yes, you heard it right. Bob, the space voyager, has aged less than Alice, who remained on Earth. A striking asymmetry has manifested in the twins' aging process. This might seem counterintuitive, but it's a fascinating consequence of the relative nature of time, a concept at the heart of Einstein's theory of relativity. The crucial turnaround when Bob changed his motion's direction created this asymmetry. From that moment, time started behaving differently for our twins. In essence, the twin paradox isn't just a thought experiment, but a profound insight into the malleable fabric of time itself. It challenges our conventional understanding of time and aging. But how can this be? They were born at the same time. This fascinating paradox lies in the change in velocity during the turnaround. You see, at the heart of the twin paradox is the phenomenon of time dilation, a direct consequence of Einstein's theory of relativity. When Bob turned his spaceship around to return to Earth, he wasn't just changing direction, he was changing the fundamental reference frame of his journey. This change in velocity introduced an asymmetry into the twins' experiences of time. The key to resolving the paradox lies in this asymmetry. While both Alice and Bob experienced time passing in what seemed like a normal way to each of them, the fact is, their experiences were anything but identical. Alice, who remained stationary on Earth, was an observer in an inertial frame of reference. She experienced time at a constant rate throughout. Bob, however, was not in an inertial frame. His journey involved acceleration and deceleration, and according to relativity, this has a profound effect on the passage of time. When Bob accelerated away from Earth and then decelerated to make his return, he experienced less time than Alice. His clock ticked slower during the outward journey, and although it seemed to tick faster during the return, it could not make up for the lost time. Thus, on his return, Bob was younger than Alice. The twin paradox, therefore, isn't a paradox at all when we understand that time is not absolute but relative to the observer's motion. It highlights the strange and counterintuitive reality of our universe as described by the theory of relativity. In essence, the twin paradox is a testament to the malleability of time itself. It's a compelling demonstration that time, as we understand it, is intertwined with the very fabric of space and motion. This paradox underscores that time is not absolute but relative, a fascinating confirmation of Einstein's theory of relativity.